Assalamu alaikum. In this video, I'm going to show you how to solve Laplace transform of the functions like sine at divided by t. This topic called theorem number 3, dividing by t, on page 11 of 97. This example on this page tells us to determine the Laplace to these functions divided by t. So, to solve these equations or this problem, we have to test this function by using Hospital rule. How to apply Hospital rules? We have to differentiate the top الباص separately and differentiate the bottom separately. In other words, we have to apply d over dt to the top and d over dt to the bottom. مشتقة الساين هي cosine at times inside, differentiate of the inside, over d over dt to t is equal to 1. And then we have to take the limit to the result when t close to 0 to these functions. In other words, put t equal to 0, cosine 0 is 1 times a, the result will be a or any constant, so the Hospital rules is satisfied. Once we did this step, we have to solve this problem by using the Theorem 3. So, Laplace to the functions sine at divided by t is 1 over t is equivalent to the integration. So, integrations or the integrations start from s to infinity to the Laplace of the functions or of the top sine d sigma. So sigma starts from s to infinity. Equal from s to infinity, Laplace to sine at is sigma over sigma square plus a square d sigma. And now this integrations is equivalent, or the result of this integration is tan inverse sigma over a, and the integration starts from s to infinity. This from year 1. Have a look to the tables regarding to the integrations of the functions. Now we are going to apply the limits on the functions. So we have tan inverse to the infinity minus tan inverse to s over A. Also, we have to remember that tan inverse to infinity equal pi over 2. And also, we have to remember that tan inverse A over S minus tan inverse to S over A equal to pi over 2. Or we can rewrite it tan inverse A over S equal pi over 2 minus tan inverse S over A. This part is exactly match this one. Pi over 2 minus tan inverse S over A. So the Laplace transform to the function sine at over t equal tan inverse A over S. So this is the solutions of this function using Laplace transform and theorem number 3. So now I'm gonna to show you more example regarding to how to solve a functions divided by t using Laplace transforms and with theorem 3. So the example is on page number 2, example number 2 on page number 12. Tell us find the Laplace of the function 1 minus cosine 2t over t. Solution. So the first step we have to do is use or apply the Hospital rules to the functions. So we have to differentiate the functions up down. 1 minus cosine 2t over d over dt to the t equal 2 sine 2t over 1, and take the limit t close to 0 to the function 2 sine 2 0 over 1, which is equal 0 over 1 and equal 0. So the Hospital rules is satisfied. Now I'm going to apply or to solve this function using Laplace transform and with theorem number 3. Laplace transform of the function 1 minus cosine 2t over t equal the integrations starts from s or sigma starts from x to infinity. This integration 1 over t, this 1 over t to the functions, and don't forget to take the Laplace to the top cosine 2t d sigma equal integration starts from s to infinity. Laplace 1 over s or 1 over sigma minus Laplace cosine 2t is sigma over sigma square plus 4 d sigma. And now we have to remember that integration 1 over x dx equal ln to x. إذا كانت مشتقة المقام متوفرة في الباص فإذا الانتجريشن أو ناتج الانتجريشن لهذا المقدار هو ln للمقام. I'm going to apply these or this property on both this part and this part. So it is equal ln sigma minus ln sigma square plus 4. Don't forget the limit of integration start from s to infinity. So what we have to do next, just we have to remember that if you want to apply the integrations to this part, you have to provide the differentiate of the bottom. يعني إذا كنت تشتق هذا المقدار يجب أن تكون مشتقة المقام متوفرة. مشتقة المقام هي 2 سيجما. موجود عندنا فقط بالتوب أو بالباص عندنا فقط سيجما، فنحتاج نضرب 2 على 2. الاثنين اللي بالأبار نحتاجها حتى يتم التكامل والنص يخرج إلى برا المقدار. So now we have to remember that if we have a ln b, we can rewrite it by using ln properties, which is ln b to power of a. So I'm going to apply this property on this part. So ln sigma minus ln sigma square plus 4 to power half. And now also you have to remember, if we have ln a minus ln b, it is equal to ln a over ln or over b. So I'm gonna to use this properties on this part. So ln sigma over sigma square plus 4 to power half. Don't forget the limits of the integral. And also للتخلص من الأس اللي موجود بالمقام بالإمكان أن نربع المقدار كله، وهذا يعطينا الناتج سيجما سكوير over sigma square plus 4، وهذا from sigma equal to s and to infinity. And now all we need to do here is substitute the limits of the integrations on this part. Ln sigma square s square over s square plus 4 minus ln s square over s square plus 4. This part, when we substitute s to infinity and this s to infinity, before substitute s to infinity, we have to do something to make it clear. So ln divided the top by s square and the bottom by s square plus 4 over s square. So this is going to be 1, and this is going to be 1, and this is going to be 0 when s goes to infinity. So this part going to be 1. So ln 1 is equal to 0. So this part going to be 0 minus ln s square over s square plus 4. So again, I'm gonna be apply this property on this part. We have here minus 1, so it is ln s square over s square plus 4 to minus 1, which is equal ln s square plus 4 over s square, and this is the solutions of the functions using Theorem 3, which is functions divided by t. Thanks for listening. See you later.